Something with even exponents. That's right. Now, if it has all even exponents, what does that mean it will look like on the graph? Anybody remember that? Yes. Symmetrical over the y-axis. Now, why is that helpful to you if I'm not a big stickler about sketching? Here's why. If a function like this one, I've chosen an even function. If a function is even, meaning it's symmetrical around the y-axis, that's a good thing for you, because if I said solve that, find all the roots, okay? You could start factoring, you can start doing this and that. How many do we need to take out of that to get it down to a quadratic? If it's 4 now, and we need to get it to a power of 2, how many do I have to take out to get it there? 2. So you would have to do a bunch of stuff that I'm going to show you today. But if you know it's an even function, and you know it's symmetrical, then that means whenever you find a negative root, then you've also found a positive root, and vice versa. Because if it has to be symmetrical, everything that happens on one side of the axis has to happen on the other side. So for example, if I plug 2 into that function, what do I get? 0, which means it's a root. I have found 2 to be one of the roots of my function. What's another one? Just negative 2. Now that one's very obvious because you could plug negative 2 in just as easily. But there might be some that are much lengthier than this, like x to the 6th, 17x to the 4th. A long even function. And if you find one root, you've actually found 2. So you can now just take both of these out back to back using synthetic division and get straight down into the power of 2 equation, the quadratic equation. Come in. So that's why it's good to know that. 2.5, the rational zero theorem. Now, notice, it does not ask us to solve these problems. It's simply asking us to list all the possible rational zeros. And I'll explain what that means. When you solve these functions for all of their roots, you could get nice numbers like 2 and negative 4 and 1/2. You could get idiot numbers, ugly decimals, ugly fractions. You could get imaginary numbers, things that don't even show up when you graph it. Which, by the way, if you ever get, well, I'll cover that in a minute, I guess. So, let me ask you this. When you were first taught to factor, all your teachers said what? They said, look for numbers that multiply to get this last number, correct? Nothing has changed since then. Since you learned that in pre-algebra, nothing has changed. The rational zero theorem simply states, if you're going to have a rational number be a root to your function, a rational number by definition is a number that can be very easily represented as a fraction. So like 2, 3, 1/3, 2/4, which would be 1/2. Any of those are rational numbers. And the rational zero theorem states, if you are going to have a rational root to a function, it is going to be of the form p over q, where p are the factors of your last term, and q is the coefficient of your first term. The rational zero theorem says, if you're going to have a rational root, it's going to be of the form p over q, where p is your last number, and q is your leading coefficient, which in this case is 1. So, here's how you do this. Number 1, first thing you have to do, list all, just like you did back in pre-algebra, list all the factors of 4. What are they? 1, 2, and 4. And now you have to take into consideration positive and negative. Always. That's not just because it's minus. You always have to do that. What is our leading coefficient? It's just 1. Well, that's awesome. Whenever it's just 1, then that's the only thing you have to worry about. 1. Now, what I'm asking from you in your answers, give me all possible combinations of p over q. So that's 1 over 1, 2 over 1, and 4 over 1, positive or negative. And there's only 6, plus or minus 1, 2, and 4. If this function is going to have a root that you could even hope to find, in an easy way, it's going to be one of these. And that's all I'm asking you for right now. And we're going to practice that some more before we do the next step. But hopefully now you can see what the next step's going to be. Today I'm not going to say, hey, choose the root, take it out and find the rest. You're going to have to just find all of them without graphing it. And how you're going to do that is, you're going to make yourself a list of places to start looking. And then you have to just check all of these using yesterday's remainder theorem, where you just plug it in, see if it equals 0. And if it does, you take it out. But we'll get to that in a minute. Let's practice our P over Q's first. How about number 3? Number 3. What are my P values going to be, Sarah? That's right. Plus or minus 1, 2, 3, and 6. Jordan, what are my Q values going to be? 1 and 3. That's right. So all my possible P over Q's are going to be what, Jalen? Okay. And? Very good. We didn't even cover this. Which was already written. I don't even have to bother with 3 over 3. You're right. Because 3 over 3 is already covered in 1, and 6 over 3 is already covered in the 2. So this is it. Plus or minus those possibilities. And that's all you have to do on the first few problems, is list out your P over Q's. Raise your hand if you have a question about where we are getting those numbers. This, the P, this is number 3, are the factors of the last number. What numbers can you multiply to get 6? 1 and 6, and 2 and 3. That's it. That's the only thing you can possibly multiply. Your Q's are the factors of your first number, which are just 1 and 3, since it's a prime number. So then all you have to do is list all possible P over Q's. 1 over 1, 2 over 1, 3 over 1, 6 over 1. 1 over 3, 2 over 3, and then 3 over 3, which is just 1, and 6 over 3, which is just 2. That's what they're going to say. Other questions? Let's put this into action. Step A, list the possible rational zeros, P over Q. Part B, use synthetic division or the remainder theorem, which means you can plug it in if you choose to see which of those work and which ones don't work. And C, use that knowledge to find the rest of them. Don't reinvent the wheel here. Let's look at number 9. How many do I need to take out of that to get it down to a quadratic, a power of 2? It's 3 here. How many do I need to take out of that to get it down to a 2? Just 1. Once you find 1, don't keep looking for things. Go ahead and take it out. Because once you take it out, you'll be down to a quadratic, and you can just use the quadratic formula to find the other 2. Because they might not even be rational numbers. They may be imaginary. Who knows? So, yep, that's all we're doing. Yes, except I'm not going to give you anywhere to start like I did yesterday. Okay, so part A. What are my possible P over Q's? Let's just jump straight into the actual list. Plus or minus what? And that's it. Because the first number is a prime, or it's just 1, so we don't have anything else to divide by. Okay, so we can do the remainder theorem. You can choose to plug it in if that's what you prefer, or you can do synthetic division. I like synthetic. I always just like to start with the easiest ones. Let's hope that positive 1 works. And I'm going to divide that out. And now what am I hoping to see here? Very nice. A 0 remainder. Drop the 1, multiply, add, multiply, add, multiply, darn. Not a 0 remainder. So, that didn't help us. We found that 1 is not a root of this function. So, we have to try something else. How about negative 1? So that's 1, 1, negative 4, negative 4. Let's try that. 1, negative 1, 0, 0, negative 4. Does this give me a 0 remainder? Yes, which means I've currently factored it down to this. X plus 1 with a depressed polynomial of x squared minus 4. Now, if you're a good factorer, then by all means just factor that thing. What would that factor down into? Remember, if you don't have a b term, you could always just set that equal to 0. If you're ever missing a middle term, just set it equal to 0. Add the 4. And what's x going to be? Plus or minus 2. Plus 2 and minus 2. So what are all my zeros? Very good. Negative 1, positive 2, and negative 2. And you have solved that problem. Now look, all three of those were on our list. Yay. Here's another reason. Well, no, not going to bother saying that yet. Yes, sir. Right here. We started with a cube, so now it's x squared. 1x squared plus 0x minus 4. Our depressed polynomial. Good question. I should have elaborated that. Let's look at 11 or 15. Pick one. 15. Let's use one without a 1 as a leading coefficient, because those are the harder ones. Yes, you can. Yes, you can. Go. I'll work it behind the screen where you can't see it. Yes, I can. Yeah. Hold on. Just don't forget what you were asked to do. P's over Q's. Find out which one's a root, and then find all the roots. Yeah, the question that will come around and answer that question. In just a second, I'll work this one, and then I'll let someone else work the next example on the board. There should be at least one that works every time. You should never have one where none of them work. Sometimes it'll be the last one you check. You're lucky. In my first year or two, I did stuff with like 50 possibilities, and it was a 49 number. I've gotten nicer. Yeah. Yeah, it was hilarious. They came up behind and they were oh, hold on. Yeah. No. You found the one word, right? You agree with it? Oh, yeah, that's what negative b. B squared minus 4ac. Okay, let's do this thing. When we get into chapter 4. When we start using trigonometry. Let's work this thing. Yeah, do it. You're right. Aw, you don't like this. It gets fun when you get good at it. And that's going to happen sooner than you think. Now, I don't permit the use of calculators, but at the end of this example, I'm going to graph this and show you why the answer is what it is. Okay, here we go. What is one that someone found to work? Awesome. 2, negative 4. Okay, depressed polynomial. Power of 2 equation, the quadratic equation. Negative b plus or minus b squared minus 4ac. Now, some of you probably had a little alarm going off in your head because you said, hey, wait a second, that's the square root of a negative number, and you are correct. That would give you negative 2 plus or minus 2i over 4, chillax, which would be negative 1 plus or minus I over 2 after you reduced it. And that's true. Those are the other two roots. And you might be like, how would you even graph that? Well, I'll show you. Let's look at what that would look like on a calculator if you were to be looking at a graph of this function. Clear. Y equals. Now, you can use your calculators on your homework to check your answers. Just don't get used to them since you can't use them on the test. 6x squared plus 5x plus 2. Now, how many times, before I graph this, how many actual numbers did we get as answers? Not imaginary, actual numbers. Just one, and it was -2, right? So that means it's only going to cross one time. There it crosses at -2, and it never crosses again. Hence, why the other two are imaginary. Because it never actually crosses again. But it couldn't just not give us an answer, because our degree was 3, which implies we should have 3 answers. That's why one of them was real, and 2 of them. But see, that's why I say don't just sit there and try to factor. You could have tried to factor this so you were purple in the face, but unless it ever dawned on you to think of this, which if it did, I'd be really impressed, then you were never going to get that. So once you get down to a quadratic, use that equation. And yes, that is an answer, and that's what you're going to need to write today. -2, comma, that. -1 plus I over 2 and -1 minus I over 2. So, which one are the answers? And -2. There's 3 of them. Both the imaginaries and the -2. That's right. Questions? Let's do another one. But let's step it up. Same exact thing. Ooh, who's feeling just like muchos confidentios? Marco. I'll come help you. Marco, come here. Now, I'm really throwing Marco off the deep end of the pool here, because how many does he have to find in order for this to... He has to find 2 of them that work. You want me to start you with a cube? Let's start you with a cube, and then we'll do a 4th here in a second. Just kidding. Marco is instead going to work number 21. You're on 21, sir. Yes, work it along with him. Technology is really bad. It's okay. Just watch my screen. It's harder if you watch the board. So when you need to erase, just make a mark on there so you can erase it. Oh, I'm sorry. Click the pen. It's on the toolbar. It's the one with the little... Right there. This one? I can't see it.
Second one from top?
Yes. Okay. Now make a mark. Anyway. Now, push in the tip of the button right there and go over that and that erase. So if you need to erase, that's how you do it. Okay?
21 you said?
Yeah. 21.
Dude.
That's good.
Which one? 21?
Yeah. Like, I wouldn't be a teacher, but I would be a doctor. I'm still getting me those ones will work. Yes. And I think you will. Here's kind of a key. If you can ever pair up your coefficients in a way that they would just naturally cancel, 30, 30, a 1's probably going to work. Or maybe -1. Find all those in your office.
Go get me this.
Raise your hand if you have a question. One.
6, my handwriting.
Yeah. No, this one's only a few. You can find one. And plug it in. You really think that's easier?
I'm just doing trial and error.
Yeah. Well, there might not be like mine. That's why you find one.
Negative 1. Nope, that's not it. Still thinking of the number.
What are you doing?
Thinking of the number. Negative 1 nor 1 don't work.
Negative 1 didn't work? Are you? Oh, you're right away. The positive 1. Oh, dang. I guess try 1/2.
Yep.
Have fun with that.
I'm gonna do some time.
No problem. Why don't you just do quadratic? So much easier. This is going to be like 1/8. Quadratic is going to be so much easier.
Look, I can't. I'm just gonna work off the base. I'll be right back. I'm just gonna work off the base so I can get my work there.
Actually, I'll tell you what, Marco. I'll tell you what. You can go teacher mode. Has anybody found one that works? What is it? Do 1/2. 1/2 works. There you go.
Alright, so you said that 1/2 works.
It doesn't matter. You guys are going to get the same thing. Tools to the death.
Okay. Well, I can get my hands straight out of this. That'd be.
Man, your handwriting's like mine.
No, that'd be a compliment for
They can figure it out. That's fine.
Alright. What's your
B squared minus 4AC. Minus 4AC. All over 2A.
Someone real quick, what's 28 squared?
Hey, somebody, what's 28 squared?
I feel like I'm running out of space. Alright, just keep that in mind. 4A would be 6. And C. I wish I could just transfer this into one big space.
All over 2A.
What'd you say it was?
They just 784.
784.
Plus 240. Man, I'm glad I gave you this problem.
That'd be 4, 4.
How's it going?
144.
It's not. But I think it's only like 8 or 10. Well, at least one of those could lift the over Q. Wow.
Square root of 544. Alright, what's the square root of 544?
Shouldn't it be plus? 784 plus that?
Ah, good point.
So it'd be 1024.
Well, that's, oh, wait, that one actually has one. I'm guessing something like that. Yeah.
Go with 32. If it's wrong, they'll tell you.
I can't think of something good thing until I can go by 6, 4. 8 over 3. There. And I can go to all the way up here again.
Okay, he's finished. While he's writing this, I'm going to decipher that writing. Okay, P's, Q's, P over Q's. Now, some people tried 1/2 first, some people tried -5 first. It shouldn't have mattered. Either way, you take out whichever one you find works. For him, it was 1/2. His compressed polynomial was this. If you took out -5, it was different, but you should still get the same answer. Then you take your quadratic, plug it in, and after he did all that, he got 1/2. I think that says 1/3 and -5.
Yes.
And now notice, all 3 of those are rational, and all 3 of them were on his list.
I think I'm going to send with some pencil and paper.
Thank you.
It's just moving in such limited space.
Very much. Oh, look, only 6 more slides. Just kidding. Not really. Okay. Questions on that problem? Good question. They don't get harder. No, not necessarily. I mean, to say it gets longer, technically it gets. The process is the same. To say it gets longer is like throwing another 10 feet onto a mile run. It's like marginally longer. Let me just show you. Oh, stop it. Technically, this is longer, but I think you will see the only thing that takes longer is you have like one more thing of synthetic division. That's it. We're just going to work this one together because everything's the same except we have to take 2 of them out to get down to a square, which doesn't change anything. We just have to do an extra synthetic division. So, well, while you're writing it down, I'm going to try my new text pen. Yeah, I'm not going to do this. No. Hold on. Not worth it. Not worth it. You all can just struggle through it. It doesn't matter that much to me. Oh no, our feelings. Get over it. Okay. P over Q. Plus or minus 1, 2, and 4. So, let's try 1. 1, -2, -5, 8, and 4. 1, 1, -1, -1, -6, -6, 2, and not going to work. Sad face. So, you want me to try number 4? Number 4. Okay. Then you could do this. In your book, I believe they show this. I've never done this. You can make yourself like a little chart via synthetic. I think it's harder like this. But in your book, I think they do this, where they write down all the things you're going to take out. That way you can just keep doing it by column. Fine, we'll do it like that. Except it's not up in the corner, it's like next to it. So you drop the 1, multiply 1 plus negative 2, multiply negative 1 plus negative 5, multiply, multiply. So it's still not a 0. This is our remainder column. Okay, I'll do this. Let's try negative 1. Now the 1s are all going to come down. No matter how many times we do this, the first number just comes down. Negative 1 plus negative 2 is negative 3. Positive 3 plus negative 5 is negative 2. Positive 2 plus 8 is 6. Negative 6 plus 4 is negative 2. Sad face. Let's try 2. 2 plus negative 2 is 0. 0 times negative 5 plus... I don't think so. Did I? You're right, it would be 10. But we're still going to get it wrong. Okay. Negative 10 plus 8 is negative 2. Negative 4 plus 4 is 0. But, here's the catch. Remember how I said it gets longer? We have to find 2 of them. But, no big deal. We just have to... Here's the thing about finding a second one. Don't plug it into your original. Plug it into your depressed polynomial. Because right now, here's how we factored this. This is how we factored this as of right now. This piece is done. We're setting it aside. So we're going to use the same numbers. You don't have to do PQ over Q. We don't have to do all that stuff again. It's going to be on the same list. And here's the thing. If 1 and negative 1 didn't work before, they're not going to work now. So you still don't have to try that. However, you do have to do 2 again, because it might be a double root. So we're going to start with 2. But our new is 1, 0, negative 5, and negative 2. That's our remainder column. Here we go. 2 plus 0, 4 plus negative 5, negative 2 plus negative 2, so it didn't work a second time. But you always need to try, if you're going to take multiple out, you have to try, if 1 works, you have to try it again. It may be a double root. So let's try negative 2 this time. Negative 2 plus 0. 4 plus negative 5. Positive 2 plus negative 2. Eureka! We've found the other one. Now that's how it's longer. You still did this last set of problems. The only thing you add to this one is this step. Because from here, you're right back into the quadratic and everything's the same again. That's right. Because here's how we've factored it right now. It's now been factored into x minus 2, right here, x plus 2, right here, and our new depressed polynomial, which you now have to do the quadratic equation on. Negative b plus or minus b squared minus, okay. I'm running out of space. Okay. Where did I get what? Right here? Oh, sugar daddy, why didn't you mention that sooner? Yes, I messed that up. No, oh wait, no, that's right. Never mind, we're good. I didn't see something. Look, we're fine. I thought I messed up, but we're okay. 1x cubed plus 0x squared plus negative 5x minus 2. The remainder column. That's just to remind you that this is the number we're looking for. We're looking for 0.
Okay, don't do this.
You asked me to do the chart. I never do the chart. Ever. But you're like, we can't erase. Well, fine. Next time I'll just rewrite it. I bought you a big eraser. I'm not doing anything. I'm scrolling, but that's it. We're not done with this one yet. We're not. Yes. You only use the quadratic when you get down to a power of 2. That's what a quadratic is. That's when you can use the quadratic formula. Now, I'll tell you what. We've only got 1,300 seconds left. So, I'm going to break this lesson into 2 equal parts. Today, we're going to do all the power of 3 ones. So you should only have to do the 1-step ones. Tomorrow, we're going to do all the greater than power of 3 ones. So, now if you want to get ahead on tomorrow, then by all means do as many as you want. But we're going to do these tomorrow. Here was your assignment. Hold on. Chillax. Calm down, okay? Okay? Oh, wait. I'm not done yet. Good gosh. But wait a minute. We have to assume that means all. For the love of goodness. Bunch of freaker-outers. Now those 2 will still be bonus tomorrow, so if you would like to work on those, but I haven't taught them yet. So I'm just going to take them off. I don't want people asking. It'll be bonus tomorrow. There's your assignment.